Let's begin with a high-level picture of a system that includes your software application. The target consists of all hardware and software in the system. The hardware or platform includes the processor, RAM, flash, interrupt controller, timers, etc. And the software or configuration includes application software, the DOS kernel, platform abstraction layer and bootstrap, and the registry. The DOS registry is where application designers specify budgets, quotas, access rights, including access rights to I/O that can be either memory mapped or I/O memory. Now let's talk about processes and threads within an application. An application typically has multiple processes where each process is an executable file and is associated with a single level of design assurance. Each process has its own address space, CPU quota, access to hardware resources, and kernel resources. DOS guarantees availability of all process resources as specified in the registry. Processes are the software units responsible for managing and enforcing space partitioning. In our example, the application consists of one parent process and two child processes. A parent process is one that creates other processes known as child processes. DOS provides two methods for creating a process, auto creation and dynamic creation. We'll define our parent process as auto created, so it is automatically created at system startup. And both child processes will be defined as dynamically created by the parent process at runtime. Within the parent process, there are two threads, main and refresh display. The main thread creates child 1 process and also creates the refresh display thread. When this thread runs, it creates child 2 process every 5 seconds. Each child process has a single thread. A thread is a function within your executable, such as main and refresh display. Each thread executes at a user-defined periodic rate as specified in the registry, and at the start of each period, the highest priority thread is scheduled to run. DOS enforces time partitioning via a patented rate monotonic scheduler that guarantees one thread cannot steal time from another thread. DOS does allow unused CPU time to be used by other threads defined as slack consumers, which enables 100% CPU utilization. Within DOS, a thread is the software component that enforces time partitioning. The DOS registry is a single binary file that defines how DOS will behave on a specific target. The Process Developer XML file describes the resources needed by each executable. The registry data is customized by the application developer to include process and thread templates, quotas for all kernel objects, and properties of the platform. The registry is used by the DOS kernel running on the platform to enforce space and time partition.